Okay, today I'm going to show you, I've done several problems on YouTube where I solve linear programming problems using Excel. So I'm gonna do the same thing here. I'm gonna show you how to solve this problem on Excel using both graphical procedure and using Excel solver. It's a linear programming problem. And I got this problem out of this book here, an Introduction to Management Science by Anderson. Here's the ISBN, and this is the book I use for my quantitative methods class. So if you're interested in quantitative approaches to decision making, this is a very good book. So, okay, so what I'm going to do, what I did is to save time, I just took this problem here, as it's stated right here, and I retyped it in this way here. I called this constraint 1, constraint 2, and constraint 3, and I typed it in here. And then I also retyped what they want us to find. So to save time, I think what we should do is just pause the video. And you guys, if you want to follow along with me on Excel, at least do this much. That way it'll save like 10-15 minutes off the video. So go ahead and pause the video right now and go ahead and type this into your Excel. Also, I believe I'll try to put a link to the spreadsheet, and then you could probably just erase everything up to here. But anyway, so you should have solved the Visio or tried to download the spreadsheet that I'll have in the comments for this problem. And let's go ahead and proceed. So I'm going to go ahead and do the solution. And the first thing like I said, I'm going to solve it graphically first. So in order to solve it graphically, you want to find the intercepts. So I'm going to do A. And the first thing I want to do is I want to find the intercepts. And we're going to find the X and the Y intercept for each constraint. So first we'll do the first constraint. And so we're going to say if X is 0, what does Y have to be? Well, in this first constraint, if 0 times 1 is 0, so that term goes away. So 3y equals 9, what is y? Well, it's pretty easy to solve for. You're just going to go equals 9 divided by 3. Of course, we know it's 3, but let's just go ahead and do it with math. And then we can say if this is 0, then the x-intercept has to be equal to 9 divided by 1. And so we'll just go ahead and very quickly do this for the other constraints. Constraint 2. We'll say x is 0, then y has to be equal to 10 divided by 2, and if y is 0, then x has to be equal to 10 divided by 2, and we'll do the last constraint, get the intercepts for the last constraint, so we can graph it. We're going to say x is 0, and this equals 18 divided by 2, and we say if y is 0, then this x has to be equal to 18 divided by 6. So now we have, 18 divided by this. Okay, so I'm going to move this out of the way a little bit because we already have the problem restated over here. So now I simply have to graph it. And if you've watched any of my other videos, graphing isn't too hard. We're just going to graph this first one. So I'm going to go insert. And we're going to insert the scatter chart like this. And we're going to double check at x is 0 as y 3. No, it's not. So I'm going to go up here. I'm going to go switch row and columns. I can say x is 0, y is 3, 0, 3. X is 9, y is 0. So that looks good. I'm going to go ahead and erase the title. And then I'm going to go up here to select data. Now I'm going very fast because I've showed this in other videos. And also, if you get behind, just pause the video or replay it. So now I'm going to go ahead and label that. So I'm going to go to this first series. I'm going to go edit. And the series name, we're just going to call constraint 1. We're going to add some more constraints. I'm going to say this, I'm going to do constraint 2. The x values for constraint 2 are right here. And the y values are, we got to delete this, or it won't work. There's no highlight and just put over. You got to delete it first. Is that? And see, as I add the constraint, see how it's graphing them there. And then we're going to add one more constraint. We're going to go constraint 3. The x values are here. Delete this. The y values are here. And we have all 3 constraints. I can go okay. I can add some information. Now remember, I have to be clicked on the chart, and then I have this contextual chart tools menu that comes up. I want to go into the design tab, and I want to go to add chart element. I'm going to go axis titles, primary and horizontal. I'm going to go up here. I'm going to go equals X, because it's my X axis. And then I'm going to go add chart title, axis titles, primary vertical. I'm going to go here equals Y. So now I have my X and Y axes. And the last thing I want to do is add a legend. So I go back to add chart element. I'll go add legend. I'm going to say to the right. I'm going to move this. And then, okay, so now we have, so that's very easy, right? It's a lot easier than doing it on paper. We're able to graph that very quickly. So now, so it says to solve it to the graphical method. So the first thing we have to do, let me bring this up here. So we can see that these are all greater than or equal to. Normally, let me show you a little shortcut. If you see greater than or equal to, that usually means to the right and up. If you see less than or equal to, that means normally you're going to shade it to the left and down. Okay? And since these are all greater than or equal to, it's right or up. Now we could test this. Let's say if to the left and down would be this area, like 0, 0 is to the left and down for all three of these. I can test this point to see if that's true. I can say 0 times 1, well 0 times 1 is 0, 0 times 3 is 0, 0 plus 0 is 0, and 0, is that greater than or equal to 9? No, so I would not shade it in this direction because that is not true for that point. So all these, so this would all be shaded up. Now this is a minimization problem. It says to minimize, right? So what I'm going to do is I would shade this area here, and it'd be bounded by, now remember, this constraint here says X and Y are greater than 0. That means we're going to be in this, the lower bound on this is going to be the Y-axis and the X-axis. You're going to stay in the first quadrant in this solution. So if I would, so this for the, let's go to the first constraint. The first constraint would be bounded by the Y-axis, and then we go along here, and it'd be bounded by the X-axis, so you'd shade gray everything in that area. I would do the same thing since these are all greater than equal. I'd shade them all to the right and up, right? And then this one would be shaded also bounded by this X and Y axis, and this one would also be shaded. So if you can picture this, can you visualize that these are all be light gray, but this would be where all three from the X axis to this point, to that point, to that point, to that point, to that point, all of that would be my feasible region. Okay, so my feasible region would be right between bounded by here. This would go to infinity, and then here, then here, then here, and then infinity. So the feasible region is bounded by 4 points. This point, that point, that point, and that point. There's no points there because it goes to infinity. So I have to find, those are called corner points in my feasible region. So I'm going to find my corner points now. And I'm going to go ahead and put X and Y again. And so these we can read off. Like if I wave over, this is 0, 9. So I could put that in here, 0. I can just type it. And then this one here I can also read off, it's 9 and 0. Now this one here, probably don't have to read it out. We probably don't have to solve for it. So I'm probably not going to solve for it on this problem. You can see that it's 3 and 2. Okay. Now let me just show you once. If I wouldn't be able to see where that point was, let me show you how you would solve for it. Normally they have to be next to each other. So this is a gray and the orange. So that's constraint 2 and 3. If they're not next to each other, you got to put them next to each other. But I can solve for it right here. So I want my answer right here. So I'm going to use something called matrix multiplication. I'm going to go equals matrix multiply. And I want to solve. I have to take the inverse of this 2 by 2 array. So I'm going to go matrix inverse. And then I'm going to highlight this. Okay. So it equals, so that's a 2 by 2. And then I'm going to take it times, this right here. So this is a 2 by 2 times a 2 by 1. All right. So the way this works is 2 rows by 2 columns, and this is 2 rows by 1 column. So it's a 2 by 2 times a 2 by 1. The way matrix multiplication works, the inner terms have to be the same. So it's a 2 by 2 times a 2 by 1. The inner terms are 2 and 2, and the outer terms are what size the matrix is going to be. So a 2 by 2 times a 2 by 1, the outer terms are 2 and 1, so it'd be a 2 by 1. Now the problem is my answer here is a 1 by 2, so I need to close this, and then I need to go to the front here, and I got to go transpose to make it into and put a parentheses on the end. I want to transpose to make it into a 1 by 2. And then I'm going to go ahead and hold down Control, hold down Shift, and hit Enter. And sure enough, now I typed it in there wrong. I said 3, 2, but now since I solved for it, it's actually 2 on the X and 3 on the Y, right? So it's probably good I did it that way. Let me put the formula in here, so you see how I did that. I just need to do one of them. Now, the only way you can get this little bracket here is by, when you highlight where your answer is, you got to hit Control Shift Enter after you type all this in there. You would type everything in except for the little bracket. Okay, so I'm not going to do the next one the same way. I'll just go ahead and you know what I could do. Let me show you this. So I'm going to drag this down. Okay, so what is this pointing to? Well, now we want to do, this is the beauty of Excel. I've done this once, and now the first one was constraint 2 and 3. Right, now let's do constraint 1 and 2, which is right here. So I can drag this up to where constraint 1 and 2 are, and drag this up to constraint 1 and 2. And then if I hit Control Shift Enter, now that shows to be at 3 and 2, which is what that one is. Okay. So I didn't have to do it twice. So now I have all my corner points. So I'm going to move this out of the way for now, because I want to figure out my minimum. Okay. And all I would do is I would take this first point, I take 0 times 8 plus 9 times 12. No, I'm sorry. I take, 0 times 8 times 9 times 12. And I'll do that for each one of these, but I'm going to do a shortcut again. I'm going to say equals M multiply. I want to take all of these, and I want to multiply. So that's a 4 by 2, and I want to multiply them times this, which is a 1 by 2. Remember, the insides have to be turned. It has to be a 2 by 1 because the other one is a 4 by 2. So it has to be a 4 by 2 times a 2 by 1. So I have to transpose this to make it into a 2 by 1 instead of a 1 by 2. And then I hit Control Shift Enter, and it gives us all my constraints. Now, we want to minimize this. Now I'm going to do this. Trust me here, there's a reason I'm doing this. So I'm going to highlight these, and I'm going to go up here into Conditional Formatting, and I'm going to go top and bottom rows, and I want bottom 10 items because I want to minimize. If I was doing maximizing, I'd do top 10 items. So I'm going to go bottom 10 items, but I just want the bottom 1. I want the minimum. And let's go ahead and make that yellow, and that shows that this is the minimum. So this point here at x of 3, y and 2 is the solution. Okay, so that answers the first part. It says find the optimal solution using the graphical method. So in this case, x of 3, y and 2 is 48. So so that would be the solution using the graphical method. Now you could also use solver. So I'm going to Excel solver method, which is a lot faster. And I'll say a solution using Excel solver. How's that? Okay. So using that method, I've done this in other videos too. I'm gonna take these. I'm just gonna set it up. I'm gonna put this here, and then I'm just gonna guess x and y. So I'll put x here and y here. And then I'm going to do some matrix multiplication here. I'm going to go equals matrix multiply. And I want to take all of these, and I want to take them times the transpose of whatever answer I'm guessing down here. Control, close the parentheses twice, Control Shift Enter. I didn't put anything in here, so let's just put 2 and 2. We'll just guess. So now we're going to make Excel guess this in order to find the minimum that. But before we do that, we have to put these things in here. So I'm going to copy this. And then here I'm going to go equals this, like so. Okay, so now, because these have to be greater than, this has to be greater than that, so that's not solving it. So maybe if we went 3 and 3, well, at least the constraints are good, but could I do something different to get a minimum? We already know the answer is 48. But make Excel find it. So I'm going to show you really quick how to use Solver. You're going to go to the data tools. And if you don't know how to get Solver up, there's a lot of my videos show how to do that. I'm going to go to Solver. Sometime if Solver doesn't show, you can go look at one of my other videos. And we want to take this, we want to minimize it, right? We want to find the minimum by changing these two cells. I'm going to add some constraints. I'm going to say this is greater than or equal to, right? What's the greater than or equal to that? I'm going to go add. I'm going to say this is greater than or equal to this, add. And then finally this is greater than or equal to this. And I'm going to go OK. So you can see I have those constraints in here. Check this. That makes sure this happens right here. Okay. Oops, let me get rid of this. Actually, this is what we're supposed to minimize. And then we're going to use simplex and go solve. And sure enough, I'm going to go OK to take my answer. So my answer is that. And this is my minimum. So it's the same thing, 4 and 8 and 3 and 2. Okay, so that's a lot quicker way to do it. So we answered part A. Now part B says, what if this is 6? Does it change the answer? Well, we can check that very quickly. I'm going to show you another thing you can do here, and this is kind of a interesting method. I'm going to go to the Developer tab. If you don't have the Developer tab, it's already built into Excel. You would just go to File, and you go to Options, and you're going to go under Customize Ribbon, and you make sure this developer here is checked, and then go OK. Once that's checked, then it's going to show the developer check. What I want to do, I want to insert a form control. I'm going to insert a spin button, and I'm just going to put it right here. Okay. And then after I draw that button out, you can draw that button any way you want. I'm going to show you again. Let me delete this. So you go to the developer, go to insert, form control, pick this one that says spin button, and then you draw it out. You click on the upper left hand corner and draw it out like that. Okay. And you're going to right click it. You're going to go format control. And I'm going to say the current value is 8. Okay, because I'm going to control this X. The minimum value is 0, and let's say the maximum value is, I don't know, we'll say 30. And we're going to link that to this cell here where the 8 is. Okay, and then go OK. Now if I click away from it, if I hit the down arrow, that'll change. Okay, now if I right click, I can go back and format again. One thing I forgot to tell you, we're going to increment it by 1. We'll increment by just units of 1. Okay, and then I'm going to take this form control, I'm going to go copy. I'll go over here and I'll paste it. I'm going to right click on this one and go format control, and we'll change that cell link to the Y. Okay, if I click away, now this one, if I hit down, I'll go down and click this one. Okay, so now I'm going to zoom out a little bit so you can see what's going on. And zoom out a little bit more. So originally what was it? It was 8 and 12. So now we can answer some of these questions. I'm going to put that back to 12. So the first set it says, if this is 6 and this is 12, how does it change the solution? Remember, we have the solution down here. It's automatically doing it based off this graphical method we did. Now, one thing we want to say is it says we're changing the objective coefficients. If you remember, we didn't use the objective coefficient in order to graph it, right? We used these in order to find our y-intercepts, and our y-intercepts were based off our graph. So changing this does not affect our graph. The only thing that affects our graph is if we change our constraints. Okay, so let's do this. Let's do part B now. So it says, does the optional, if we change this to this, so I'm going to change the x down 2 to 6. Does this still say 42? That's what it was too, 3, 2, and the minimum was 42. So as you change this, it's still the minimum, right? 8, it's still the minimum. The answer is different, but it's still the minimum. You know, you're going to still produce 3 of this, 3 of x and 2 of y, and that's still going to give you a minimum. So it's going to change the solution, but you're still going to have the minimum amount. Okay, so let's change that back to 8 for part B. For part B, it says this is 8, but now y is 6. So I'm going to change y to 6. And as I go from 7 to 6, what happens? Or actually, when I go from anything after going 4 down, all of a sudden that's not the minimum anymore. So that changes my solution. It's a different answer. Okay, so what is the solution? Well, we can still use the graphical method. We can change this to, what was it, 6? So 6, the answer is 3, 2 with a minimum of 34. Okay, the first part, if you use a graphical method to solve it, that was 12. And this was 6. The answer is 3 and 2 and 42. So you can solve it automatically just by changing. Now, these things here, I wouldn't have had to put them. I could have typed 6 in here, right? And that does the same thing. I was just using the arrows to change it. Okay, so that's how you would solve these. Hopefully this is making sense. I'm going a little bit quick. And then finally it says, here's the computer solution. I wrote it here, but I have it here. It says the allowable increase on x is 4. What that means when you get this on a computer solution, it means that I can go up 4 and you're going to have the same, I still should do x of 3 and y of 2 in order to get the minimum. So let's try that. Let's move this up 4. It says the allowable increase on x is 4. So I can go 1, 2, 3, 4 up to 12. It still has this as the answer, 3 and 2, but the answer is 60 now instead of what it was before. And I can go the allowable decrease is 4, so I can go back to 8. I can go 1, 2, 3, 4. And now it's tied with this, but still, if I would go 3.9, if I go 5.01, which is almost 4, it's still going to stay on here. Once I go to 4, then it ties with something else, but this is still one of the solutions. Now there's 2 solutions. And we can do the same thing for y. So I'm going to move this back to 8. So if I can increase this up to 12 on y. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, it ties with something else, but this is still a reasonable solution. Or I can go down 4 from 12 and go 1, 2, 3, 4. And again, it ties with something else, but still that's a solution. So this basically is like a sensitivity analysis that tells you you're still going to have 3 and 2 as the answer. Now the minimum is actually going to change, but you're still going to want to, if you want to minimize your objective function, and it will stay at 3 and 2 within those ranges. Okay, So that's how you could read your computer instance to do a sensitivity analysis. So now I would have to do this solver every time I change something, right? Because I'm changing this objective function. So I'd have to run, instead of using this arrow, I'd have to, down here on this solution, I just have to run solver every time to see what answer I get. I could do the same thing. So these little arrows, sometimes that's handy. Some people don't realize how hard, it's all easy it is to put arrows in and have them be linked to a cell and change the link just by moving the arrows. I thought I would show you that. That's actually a good application for this problem. So hopefully that helps. I know I went pretty quick. I didn't type the answers out, but hopefully you understand by my explanation. I know this should help my quantitative methods class because I have problem 4, which is based off of problem 3. So hopefully this helps if you watch this video. Again, I'm going to put my picture up here. If you haven't subscribed, hit my picture. I'd appreciate that. If you like the video, give me a like. Thank you. Bye.